Hello everyone, I'm Kevin. This is Christophe and Gregory.
Hello.
We all come from Criteo, which is a French company that does advertisement retargeting. So in a nutshell, it's about building a profile of people on websites and then displaying ads especially tailored to them to maximize the probability that they will click on it. Anyway, what we're here is to tell you our journey as Windows expert with little Linux background. We try to integrate the LTTng pipeline in Criteo to be able to monitor .NET Core application on Linux.
So if some of you are wondering why there is a flying cat on the slide, it's because we were in the same state of mind as this cat when we started this project, okay? As Windows people going to Linux, we were like this.
That slide has a splat, right?
I mean, no. Actually, some of us didn't land very well, as you can see.
So first, a few numbers to give you the scale. Criteo is more than 8,000 servers running Windows on the online part, so processing requests. So it's not quite as big as the data centers Richard was talking about, but it's still big enough to have some very complex interactions between servers during the transaction. Why Windows? Is because many of our services are written in .NET, and up until a few months ago, it wasn't really reasonable to use something else like Windows to run .NET. On those servers, half of them are front-end servers, so receive directly HTTP requests from internet. And we process more than 200 billion HTTP requests per day. So if you do the math, that's about 600 requests per second per server, which is an average about a day. So we can go from 300 during the night to well above 1,000 during peak hours. So at this scale, you need a way to be able to tell at a glance how your data center is doing. And one of the cornerstones of our monitoring system is Grafana. Grafana is the monitoring dashboard that runs on top of Graphite, and Graphite is like a big storage for metrics. We push all kinds of metrics. We have, of course, business metrics, such as the number of ads displayed or the click conversion rate, and also all-purpose technical metrics, such as CPU usage or memory. And when things go very wrong, we rely on special kind of traces that are pushed directly by the CRR, as shown by Brian in his talk, that allow us, for instance, in this case, to monitor the GC, which is one of our main pain points when it comes to performance. I'm sure all of you are familiar with this kind of game where you have to bring the water from point A to point B by using pipes. Well, in our case, the CRR traces don't go magically from the server to the Graphite backend. And so we've got to build pipes to carry the water or the traces from each individual server to the Graphite backend. So Christophe, could you do a bit of plumbing for us?
Thank you, boss. I didn't know I was a plumber, but yeah. So on Windows, as Brian explained just before, you get the traces from ETW, so it's very low-level traces, and it's far from what we need. But based on these traces, we can write a companion service that listens to these events, and we are translating them into higher level metrics that we are able to use in Grafana. And we use the Microsoft open source trace event library to do this conversion. So most of the code is there, even for us, and that's how we get the information we need to send to Grafana. So I want to do a quick demo with one end. So let's do it. You should see some code later on. You should see. So on the left, you will have the .NET Core application that will run on my machine. It would run also on Linux, so the one on the left. Is it big enough for you, or I should increase it? It's big enough? Okay. If you need more, I can do something like this. So this is a very nice UI to trigger event that the one on the right we listen to. So we just need to get the process ID, which is 24145. That's right? I don't get my glasses, so 144. Okay, thank you. So now I'm listening to one provider. So in ETW, and I think it's the same for LTTng, you can have many providers, and the listener will just listen to this part of the event sent by this provider, which is the one for the CLR. So if on the left, I'm triggering one specific event, so let's say to the garbage collection, I want to trigger garbage collection of generation 0. On the right, you should get information, and in the information, you know that it's a gen 0. So we can translate this and send the corresponding information plus additional information such as the memory size to Grafana. Okay, you can do the same with generation 1, do the same with generation 2, you get the picture. And we can also simulate the kind of processing of what our application inside Criteo are doing, meaning that we are not doing collection, we are allocating a lot of memory. When I mean a lot, it's like gigabytes, like 10 gigabytes up to 20 or 25 gigabytes. So we kind of simulate this kind of thing with this. And as you can see, it's very fast. So the listener maps very fast all the events. So it's very good for us to get the information. So before you get dizzy, let's stop this and show you the code for that. Is the phone big enough for you? For it a bit bigger? Better? Okay, so this is the one for the right, okay? The listener. So we just get the process ID from the command line, and we start to monitor event. And this is where we start to use the open source library, the trace event, where we get the session to listen to the event. And since this is C#, what it means the using is like the lifetime of the session is from the beginning up to the end here. So the main function is the listen to event, and the listen to event, these are all the events that are provided by the trace event library, and we are listening to this event, and we get the information as arguments. And so we format the arguments in the console. So it's very easy. We do this for the event that we are interested in. So the demo was on the garbage collection, but you can get information about suspension time, about contention, when the threads are locking each other, the exception, and all that stuff. And then, once you've done that, you just start the collection. Very easy. And it's very simple. So let's go back there.
Okay, so we have been using this pipeline for years to get the traces to Grafana. But now Mesos is all the rage. There is a Mesos conference going on as we speak. And we want to migrate a large part of the services to Linux with Mesos for many reasons. We can mention licensing cost or being able to better use the hardware thanks to Mesos rebalancing capabilities. Anyway, since Microsoft has published .NET Core, we're now able to seamlessly take our .NET applications and put it on Linux. So what are we waiting for?
Seamless. It's like if we remove Windows, then we remove ETW, then we remove the events, then we remove the opportunity to translate them, then we don't have the companion service, then we don't push to Grafana and Flying Cat.
Okay, so maybe seamless wasn't the right word. But not everything is lost because, well, if you followed Brian's presentation, even on Linux, the CLR still pushes events. It's just that it doesn't push them to ETW, obviously, but it uses LTTng instead. So now we just have to build new pipes to bring the water from LTTng to Grafana. So, Gregory, can you do that for us?
Hello, I'm the second member. So, yes, from the high level, nothing changes, which means that we still have our companion that will get the CTF traces, decipher them, and analyze the corresponding CLR events, and we still have our reload matrix sent to Grafana. So let's go deeper into the architecture we chose. You've all seen that pipeline, LTTng pipeline, which is the application that uses a UST library that writes the events into ring buffers. Those ring buffers are read by the consumer agent and get the events. Those events are sent to the relay daemon. And that's it. At that point, we saw three spots where we can plug our companion. The first one was, why not reading directly from the ring buffer? Yes, that was not really a good idea because we can have tricky code and it can be complicated to maintain it later. So we step back and say, okay, why not implementing some kind of relay, but not relaying, by reading the events from the consumer DB. Same, there was no public API, so we didn't see any public API. There was no documentation about the workflow except the code, the message we have to exchange. So same as the ring buffer, can be difficult. Not too fast. Spoiler. So yes, we step back and see that, well, we can plug our companion behind the relay daemon and get the traces we want. It was a good choice. It's a good choice, I think, because we have documentation of the message exchanges. We have some tests. We can read some tests in the LTTng repository, and we use the double trace as a reference to our companion. At that point, with all this process running in the Linux box, which is 1, 2, 3 with the session, it's around 5 processes on the box. We wanted to test it on the Mesos cluster, Mesos container. So we went to our SRE guys and asked for some help and start discussions. One thing you have to know is that at Criteo, and maybe in other company, when we spawn a Mesos container, there is only the application that runs in it. And if the application misbehaves, the container is killed, and another one will respawn. And when we presented our nice architecture to the SRE guys, they freaked out. Because they all see the only multiple single point of failures. And that brings a lot of resiliency questions. So at that point, we decided to move our companion inside the process of the application. That can be done, yes, it's what we've done. But the problem is that we must ensure that the companion, when it's running, does not impact the performance of the application. Because like Kevin said, we rely a lot on performance. And to ensure that we don't, usually when you want to be sure that your code is doing well in terms of performance, you do profiling and you improve your code. And two things to remember: that we are Windows developers, so we're not used to implement debug and profile on the Linux ecosystem. And second point, for debugging and profiling, the .NET Core tuning ecosystem is not ready yet. So thanks to the LTTng TCP-based communication protocol, we were able to implement our companion on a Linux machine, Windows machine, sorry. You can see the Windows.
Read it.
And use our Verilog tools to debug it and profile it and make it really with a good performance. And then we have our CTF traces. Is that good, Christophe?
Yes, that's good because as Brian already mentioned, that the CTF traces is supported by the open source trace event library. So we are able, even on Linux, to parse these low-level traces and get the higher metrics that we need. Except that, if I remember well, the CTF traces are only supported as file format. So we are a little bit,
excuse me, the only thing I get from your sentences is that it's open source.
yes, but the current implementation just supports a file name, and here we want a live session.
Yeah, it's open source. So we can provide the LTTng session, live session support. And in fact, it's what we've done. We pushed a merge request in the GitHub repository of Trace event to have this support. And now we have our log metrics inside Grafana from an application running on Linux.
Do you have a demo or something like this?
You bet I can. Oh, yeah, this is my Linux docs. First, I run the relay daemon, and then I will set up my LTTng live session for the .NET runtime events. And then I will run my C# application. You will recognize the nice UI Christophe showed you previously. And then, like on my Windows box, like the ETW demo, what I only need is the PID of the application. And then I can trigger events. Like the first one is a garbage collection for Gen 0, the second one is a Gen 1, and the third is a Gen 2. And then I can simulate the behavior of the Criteo application running on the Mesos. And what you have to know is that the code Christophe showed you previously, the only part that changes is the session created. I will create a session. The rest is the same. We didn't do anything more. So,
It's hard for me. No more flying cat for me.
no more flying cat.
All right. So at that point, we are able to trace the performance of our .NET Core application on Linux. So we can resume the migration from Windows to Linux. What we learned from this journey is that Linux is becoming a suitable platform for .NET developers. So you can expect in the near future to see many more Windows developers coming to the Linux ecosystem. I think we also seen is that we had trouble with the LTTng documentation. So don't get us wrong, the documentation is pretty good, but clearly it is aiming at Linux for users. And when you have very little Linux background like us, there are a lot of things that are said implicitly and that took us time to figure out. So I'm sure that working together, we could improve that. And also, we mentioned how we contributed to the Microsoft Trace event library, and we intend to do more in the future. For instance, to optimize performance. I'm sure we can shave a 12 cycle here and there. And also to implement better handling of CTF traces, such as the metadata part, or maybe we can switch it completely with Web trace. That's it. I think we have a few more minutes for questions, if any, or if not, we can go back to playing cats.
Yeah.
Question? I have one for you. So you mentioned in one of the slides where someone told you that there were many points of failure and you ended up putting the kind of analyzer or consumer with the application. But I did not see how that would resolve that concern because you still have all the data path going to the LTTng processes and the relay daemon. So how does it help anything?
In fact, they saw that they cannot do anything about the LTT pipeline, so we still have those daemons, and just try to reduce by one the number of processes running in the container. So
for example, if the companion crashes, how do you know that the application is still running? The LTTng pipeline is still there, but you don't get any metrics. So the application is running, but the companion is not running. Do we need to respawn the container? How do we know that we can respawn it? This kind of question, like resiliency.
Yeah, but
and
you
the
still
more process that you have, more complicated it is to figure out if the application is misbehaving, or the whole container, or the kind of architecture that we build, and this was the kind of discussion that we had with them.
So this is actually a concern that we also have in LTTng. I mean, how do we basically get people? So we have health monitoring facilities within the consumer daemon, the session daemon, and the relay daemon. I don't know if you've seen those health. So those are APIs that you can use from a watchdog to detect whether those are working correctly, and that each thread within each of those processes are doing progress. So, I mean, you just have to add some similar facility to your monitoring application, and that you would have the whole pipeline. So that could be a good idea.
Very good, thanks.
Other questions? So about documentation, please let us know if there are things that perhaps sometimes we could put a small footnote with a link to external documentation that explains the basics of things that people are not aware of. So we don't want to load the documentation, but a small reference sometimes is very, very easy to add. So it's very good for us to get the feedback from external people as well.
Yeah, we will be glad to have.
All right. Thank you very much.
Thank you.